Move on to the next portion, that is nature of roots. This is very important. Nature of roots. So what are the nature of roots? Is it positive? Is it negative? Or is it real roots? Is it imaginary roots? So let us do that. So as you know that alpha will be equal to minus b plus d by 2a, and beta will be equal to minus b minus root d by 2a. These things, these alpha and beta, these are the roots of the equation. So these roots will only exist if and only if d is greater than equal to 0, and if the discriminant is equal to 0, then the roots will exist, but both the roots will be equal. We will come to that, but the discriminant needs to be positive. The discriminant needs to be a whole. So d needs to, the discriminant, the root under value, that value needs to fall in the set of whole numbers from 0 to infinity. Okay, so now if d is equal to b square minus 4ac, if this is greater than 0, then we can say that alpha and beta are real and unique, which means alpha and beta will not have the same value, they will have different value. Okay, now let us do something. Let us subtract alpha minus beta. Let us just do and see what happens. So this is minus b plus root d by 2a minus b minus root d by 2a. This will be equal to minus b plus root d by b plus root d by 2a. This will be equal to root d by 2a. Right. So we can see that alpha minus beta is not equal to 0, because root d, discriminant, is not 0. Discriminant over here is non-zero. D will not be 0 because this is our assumption. This has been our assumption. We are saying if, this is our case number 1, we are saying if d is greater than 0, which means we are not including 0, we have not given the equality sign over here. So d is greater than 0, which means d is a natural number. So here d is not equal to 0, and a will never be equal to 0, because if a is equal to 0, this will be undefined, and also if the leading coefficient is 0, then it will not even be an quadratic equation. So alpha minus beta is not equal to 0, so basically alpha will not be equal to beta. So that is exactly what we mean by unique. So when d is greater than 0, then alpha will not be equal to beta. Alpha and beta will be the two roots of the quadratic equation a square plus bx plus c is equal to 0, and the value of alpha plus beta, which means the alpha and beta, the numeric value will not be equal. Now we move on to case 2. If d is equal to, we all know, b square minus 4ac, this is equal to 0. If this is equal to 0, let's see what happens. If this is equal to 0, then alpha and beta will be real. It will always be real because it's not negative. It is positive. It will be real. Also, okay. So also alpha will be equal to minus b by 2a, which is equal to beta. We just need to put d equal to 0 in the expression for alpha and beta. Do you understand what I am trying to say? Alpha is minus b plus root d by 2a. We put d equal to 0 over here. So what we will get? Minus b by 2a. Because d is 0, we have assumed, we have taken if d is equal to 0. And if the expression for beta was minus b minus root d by 2a, we again put d equal to 0. This will again be minus b by 2a. So if somebody asks you, this is a very important question in MCQs, that if d is equal to 0, if the discriminant is equal to 0, then if we consider the general form of quadratic equation, then what is the value of alpha and beta? So you have to say minus b by 2a. This is a good MCQ question. Now we will move on to case number 3. So what is case number 3? Case number 3 is if d, now a natural question arises, what is the nature of the roots of the equation, the general form, when the discriminant is negative? Okay, so if the discriminant is negative, then b square, as we all know that now for 3, that is discriminant is less than 0, we have to go back. We have to go back to something. Wait, just 1 second. This is Shudacharya. This is completing the square method. You remember this, completing the square method? So basically we had, let us go to this step. Let us see this step. this one, this thing, okay. Here x plus, you're looking at this step, so d is less than 0. D is less than 0 means b square minus 4ac, this is less than 0. So if you divide the both sides by 4a square, this is 4a square, this is by 4a square means 0. So it's no use of writing 4a square over here, so I just rub it off. So this is less than 0. Now you have to now see this entire thing, this entire question, see this properly. Here in the left hand side we have a perfect square number. Perfect square number means like 9, 36, these are perfect square number. Perfect square number can never be less than 0. Perfect square number can be 0 and like perfect squares, it can never be negative, right? But here we arrive at a contradiction. What is the contradiction? The right hand side of the equation, this is the right hand side of the equation, the right hand side of the equation is less than 0. Why it is less than 0? Because we are assuming, we are taking the discriminant to be less than 0, like this. Here d is less than 0 here. So the right hand side of the equation is less than 0, but the right hand side, but the left hand side is greater than 0, is equal to or greater than 0. So we arrive at a contradiction. Thus if d is equal to b square minus 4ac, which is less than 0, therefore that is the discriminant of the quadratic equation is negative, and the equation has no real roots. Okay, so this is all you need to know right now. When you will move on to class 11, we will talk about complex numbers, that is which is represented by I. Okay, so basically those are the complex roots. The complex graphs cannot be drawn on the Cartesian plane. For that we need the Argand plane. So right now all you need to know in the 10th standard is that this is exactly why we are arriving at a contradiction. The contradiction is that the left hand side is positive, it is always equal to 0 or more than 0, that is perfect square numbers, but on the right hand side it is less than 0. So this is the contradiction that we are arriving at. Now we will do some sums. Okay, so let us go back. This is done. Yeah, we have to solve this using one second. Nature of roots. Okay, this is the first question. So what is it we have to ask is that we have to determine the nature of the roots in this following equation. Basically we need to find the roots, nothing else. We need to apply the quadratic equation formula, and we don't need to apply the quadratic equation formula, we can simply apply the discriminant. We have to check whether d is greater than 0, it is equal to 0, or d is less than 0. So in question number, let us do question number 1. In question number 1, a is 1, b is 1, and c is also 1. We will just put in we will directly put in the value d is equal to b square minus 4ac. So this is it should be minus I'm sorry, 1 second, yeah, 1 square minus 4 into 1 into 1, this is equal to minus 3. So d is less than 0, so the roots are not real. The roots are not real. Now let us move on to the next question. Here a is 2, b is 5, c is also 5. Discriminant, we will put the value d is equal to b square minus 4ac. B square means 25 minus 4 into 2 into 5. This is coming out to be minus 15. So again d is less than 0. So roots are imaginary. Okay, the roots are imaginary. So this part is done. After this part is done, let us move on to the next question. So the next question says, what is the next question? The next question says find the values of k. Find the values of k for which the following equation has real roots. You have to find the value of k for which the following equation has real roots. Okay, so this is the equation. Let us first write the values of a, b and c. A is what? K minus 12, the leading coefficient. B is what? 2k minus 12. B is 2k minus 12, and c is equal to 2. So d is equal to b square minus 4ac, that is equal to 4 k minus 12 whole square minus 4 k minus 12 into 2. Right, now this is equal to d is equal to 4 k minus 12. This comes out to be k minus 12 minus 2. Simple. We are just taking k common. We are just taking k minus 12 common. I'm sorry. We are taking k minus 12 common. So d is coming out to be, d is equal to 4 k minus 12 k minus 14. This is the value of d, right? What we are asked, we need to find the value of, we are asked to find the value of k. We need to find the value of k for which it has real roots. We will find the value of k for it has equal roots. Okay, so for equal roots, we know for equal roots d should be equal to 0. We know that, right? The discriminant should be equal to 0. So we just simply equate this equal to 0. K minus 14 is equal to 0. So k should be equal to 12 or 14. So for both the values of 12 and 14, this equation, if we put the value of k equal to 14, then the equation will have real roots. If you put the value of k as 12, then also the equation will have real roots. Okay, so this part is done. Now let's look at the next sum. The next sum says find the least positive value of k. Find the least positive value of k for which this equation has real roots. Least positive value of k, this is k. Let us write the equation. X square plus kx plus 4 is equal to 0. This is the equation. Now we need to find the least positive value. Least positive value of for equation least positive value of k for which the equation has real roots. First, let us break this question up. This question says that this equation has real roots. So what is our condition for real roots? D should be greater than or equal to 0. So D, let us find out D in this question. D is k square and 4 square, b square minus 4ac, b is k over here, so k square minus 16 is greater than or equal to 0. So k square is greater than or equal to 16, which means k is greater than or equal to 4. Simple. So the least positive value of k, the least positive value of k for which this equation has real roots, that least positive value, the answer of the least positive value is 4. So answer least positive value of k is 4. Right, it's 4. Now the next question, what is the next question? The next question says if the roots of the equation, this is the equation, this is b, this is the equation, are equal, then prove that 2b is equal to a plus c. Okay, this is a very interesting sum. They are saying that roots are equal. Roots are equal means what? D is equal to 0. Simple. D is equal to 0. So we will find D in this question. We all know A is equal to B minus C. Simple. A is equal. Achha, don't write it as E. Okay. Let the equation be px square plus qx plus r is equal to 0. This is the general form. Okay. So P here is B minus C, that is the leading coefficient. Q is C minus A and R is A minus B. So discriminant here should be Q square minus 4PR, that is B square minus 4AC, that is Q square minus 4PR. This is equal to 0. So Q square, which means C minus A whole square minus 4 B minus C A minus B is equal to 0. Pretty simple. Now C square, you just break this entire thing up. C square, just open the brackets. AC square plus A square, 4B square minus 2AC minus 4AB plus 4AC minus 4BC is equal to 0. Now C plus A minus 2B entire whole square, this is whole square, this is equal to 0. This is A plus B plus C whole square. What the formula that we are applying, it's A plus B plus C whole square. A plus B plus C whole square. What is that? It is A square plus B square plus C square plus 2 into AB plus BC plus AC. Here A is C, B is A, and this C, the entire thing is minus 2B. So c plus a minus 2b is equal to whole square is equal to 0. So simply c plus a minus 2b is equal to 0. From here we can write 2b is equal to a plus c. Hence proved. That is, this is the expression that we had that was required to be proved over here. 2b is equal to a plus c. 2b is equal to a plus c. This is done. Now let us move on to the next sum. The next sum says prove that both the roots of the equation, this is the equation, prove that both the roots of the equation, this entire equation, are real, but they are equal only when a is equal to b is equal to c. Okay. So first thing that we need to do, we need to break this entire thing up. We will just break the equation. We will write the equation as a general form. So when you will do that, you will get 3x square plus 2x as a plus b plus c, and the constant terms would be ab, bc and ac. This entire thing will be equal to 0. Okay, we just need to open the brackets and group the terms. As x square will have only one term, that is 3x square. This is x square 1, x square twice, x square thrice, so 3x square, and then we just need to group the entire the x terms over here, and then the constant terms will automatically get separated. So let d be the discriminant. We have to find the discriminant of this equation. Discriminant d is equal to 4a plus b plus c whole square. Why 4a plus b plus c whole square? Because in this equation b is equal to minus 2a plus b plus c. b, so b term is this, so b square, this is that, so this is b square, and just 1 second, let me rub this. That was b. Okay, now minus 12 this. Okay, simple. Now we just need to simplify, nothing else. We just need to simplify. So this, we will apply this formula. Okay, now look at this very carefully. The ABBC terms, those would get cut off. Okay, see this we can write it like a plus b plus c whole square minus 3 ab plus bc plus ac, right? Now d is equal to 4 a square plus b square plus c square minus ab plus bc plus ac. I'm sorry, this will be minus because this has minus over here. So close the bracket, and now d is equal to, we will take 2 inside, 2a square, 2b square, 2c square minus 2ab, you will see why, minus 2bc minus 2ac. Okay, now d is equal to 2 a minus b whole square. Why a minus b whole square? Because this and this, a minus b whole square plus b minus c whole square. Why b minus c whole square? This one b square has gone here, another b square will go here, and another term will be c minus a whole square. Simple. Now the next thing that we will do, this is a very important part. Clearly d is greater than equal to 0. Why is d greater than equal to 0? We see in the question it's not provided that d should be greater than equal to 0. Okay, yeah, it's given that they are real, the roots are real. So d, from this equation, from this, that where we have arrived, this is where we have arrived, we can assume that d is greater than 0. Why is d greater than 0? Because these all are perfect squares, so these all are positives, and it's multiplied by 2, which is a positive number. So this d is equal to 0, this entire RHS, this thing is positive, so d is greater than 0. So if d is equal to 0, then a minus b whole square plus b minus c whole square plus c minus a whole square is equal to 0. D is equal to 0. Why is d equal to 0? Because c. But they are equal. Roots are equal when the discriminant is 0. So we have assumed this. D is equal to 0. We will write here the reason is d is equal to 0. It's given in the question. We need to find the value of a, b and c, the expression actually. Now, so what? A minus b is 0. B minus c is 0. C minus a is 0. So A is equal to B, B is equal to C, C is equal to A, which implies A is equal to B is equal to C. Hence proved. That is exactly what we had to prove. Okay, so this is